Let's look at some examples of solving the work done on a system. So in this example, we have a 10-kilogram box that's being pushed along the floor with a force of 20 newtons. The box moves a distance of 5 meters across the floor. The work done on the box by the force will simply be F times D. The force applied was 20 newtons. The distance is 5 meters. So the work done is 100 joules. In this case, we have a wagon that's being pulled across a field. The force on the handle is directed at an angle of 30 degrees above the horizontal. So the force of 200 newtons is along this arrow directed up and to the right. The ground is along here. And we're going to pull this wagon a total of 20 meters. Now, because the force is directed at an angle above the horizontal, we need to determine the amount of work done by the horizontal component of the force only. When the force is not parallel to the distance, we use the function that the work is equal to the force times the distance times cosine of the angle. So in this case, the work would be 200 times the distance times the cosine of 30 degrees, which equals 3,464 joules. In this case, we have a 40-kilogram object that is moved a displacement or a distance of 15 meters. We are asked to find the force needed on this object if it's going to take 6,000 joules of energy to do this movement. So work is also measured in joules. So this is the amount of work we need to do to move the object. So if work is FD cosine theta, and in this case, the angle between the force and the displacement is 0 degrees, and the cosine of 0 degrees is 1. So then we'll have that the work done is equal to the force times the distance. The work we need to do is 6,000 joules. The force needed is unknown times the distance, 15 meters. So then the force needed would be 6,000 divided by 15, which gives us 400 newtons.